my name is Saurav, and today we are going to deal with how to draw a schematic and to generate symbol and how to draw a test bench for using Cdesigner. So first step, what you have to do is you have to go to Cdesigner _session _90nm. After going that, we have to open our terminal using open in terminal. After this, you have to write a code Cdesigner ampersand. After that, it will open the Cdesigner console. We are waiting for that. See, as you can see, it is saying Galaxy Custom Designer, so it's like Cdesigner. It opened the Cdesigner, and after opening, we have to draw a schematic over here, and we can generate symbol. I'll be telling you about all those things. See, from here, what you have to do is this is called console. After this, we have to go to file and like new and library. That means we are using it for the first time, so we have to create our own library. After clicking, we have to give our name. For example, let's say VNR. It's our library name, and coming here, import file. We have to import the file. The import file will be from Cdesigner _session _90. From here you have to go to SAED 90nm, and from here you have to go to text file, and from here you have to select this file. This file you have to select SAED _90.tf, that is text file. TF stands for text file, and you have to select open. After that, you have to click OK. It means you are overriding. Okay? Now it's done. Now you are done with your library. Now what you have to do is you have to click new. Because library is already created, you have to go for cell view. After that, see, these are all libraries where you have to select your own. Like we have given VNR. So in this, let us try inverter. So cell name is inverter. Cell name is inverter, as you can see, and over here you have to select schematic, because we are selecting for schematic because we are drawing schematic first. Then it will automatically select schematic editor. Then press OK. So this is what we say Custom Designer schematic editor. From here, what we have to do is you have to you have to draw a schematic over here. So for example, we are drawing inverter here. So to add PMOS and NMOS, what we have to do is we have to add instance by pressing I. See, when we press I, we will get this I instance. So in this, we'll have different libraries. So for PMOS, you have to select SAED _PDK _90, and in cell, you have to select PMOS 40. 40 is 4 terminal device we are selecting. We'll consider body also. So as you can see it selected PMOS transistor. Okay. Now coming back to NMOS, we have to select NMOS. So we are gonna select NMOS 40 and same schematic. We have to place it over here. Now see, if you see, suppose if you are gone with all your schematic, if you cannot see your schematic where exactly the schematic is, then simply by pressing F, it will fit your schematic in the screen. Like now you have to use wire to connect for the connection. See, you have wire over here. So you just select this wire, and then you have to see, for example, you have to add gate of both the terminal, right? So to make use of this connection, and drain is connected. Source you have to give it to VDD. See, if you are coming with this type of thing, then you have to press escape and again select wire for VSS. Now as we have taken 4 terminals, what you have to do is we have to connect this body. This is called as body, this part, this red one. So you have to connect. In case of PMOS, you have to connect it to power supply. So we are connecting it to VDD. See, you can zoom it. See, here you can see the connection is not made. So again you have to select it like this. See, like it's coming error. So what you have to do is you have to remove this part. You double click it on it and press delete. It will delete. Again I am pressing F to fit our screen. See, by mistake the transistor has been gone by by the editing. So what you have to do is, to undo you have to press U. Again you are again you got the transistor. Now you have to join this body to, so you zoom it and do it, and if you are zooming in, then you are connecting it, right? It's done. Now the same thing with NMOS, you have to connect it to ground. Now okay, now it's over. Now what you have to do, see over here you have to add pin, like input and output you have to select, right? So I'm taking pin, input pin, and here I'm giving name IN, and you have to place it over here. Okay, and the same thing, it's output, and over here you have to select out. Over here you have to select out, because you are putting it over output, near output, right? So I'm putting over here. Now to connect this, again you need wire, connect it using wire. Now for the VDD and VSS and ground, what you have to do, you have to add instance, go to analog library, and in this just type VDD and select it, put it over here, and then select the ground and put it anywhere in our editor. Now you just you just join this. Okay, it's done. Now F again for the fit screen, again you are drawing. See, now it's done. Now whether is there any error or not, how can we check that? You have to save and simulate over here. You have to check and save option is there, you have to click on this. See, we don't have any error. Suppose we how will we get error? Suppose I'm just removing this wire. I'm just removing this wire. Now see, I have removed this wire, and see it's blinking. That means it's showing error. So we have to connect the wire. It's just a demonstration that how error will look. It will blink like this. Now I'm selecting the wire again, or else I'm undoing it. Okay, now you check and save. Now you don't have any error. So now it's done. Now we are done with our schematic. Now we have to go for the symbol. Now to create symbol, we have to go to design, and then in design you have to select new cell view, and then in the new cell view, from cell view, and nothing else you have to modify. You just select OK. See, this is the symbol you got. Now in this you can change. See, you can see over here CDS term bracket in. You can double click it and just put in, enter. Here you just put it OUT out, click, and here it's cell name. Double click on it, and because it's an inverter, I'm putting INV. And these two you can remove it off, these three. Now see, now again you have to go for check and save. Over here, check and save. See, it's not having, generally you will not get any error if the schematic is not wrong. Now let's see how to draw a schematic for our given inverter. Just go to select, and because library is already defined, you just go to cell view, and in this you have to select our library, that is VNR, and then over here just whatever the thing you want to do, you give it. Just for our understanding, just give it INV 1_TB and schematic editor. Just click OK. Now you will get this editing, like custom designer schematic editor. After getting this, you have to draw your test bench. So for that you have to press I to get the instance, and this instance, because we are writing test bench for our gate, so you have to select the library, our library, that is VNR, and after that cell name is inverter. Don't give inverter 1 or inverter T. You may be getting doubt why we are not selecting inverter 1 TB, whereas we have given the name in the beginning, because this file is going to generate after we are done with all the things. So you have to select VNR because inverters test bench we are drawing. So select inverter and then move the cursor on this editor, you will get this. Now to all this inverter we have this input and output. So input should be connected and output we have to connect. So for that you select analog library and then in cell you just put V source. I'll be explaining you why we are using and all V source now. Just put it over here and select V pulse from analog library only. Put it anywhere on the editor. Take ground. All the things you have to take it from one. Like if you are taking like VDD from analog, then you should not take ground from basic. It should be from same library. See, we have got this now. You have to take VDD one VDD you have to take. Okay, now you are done. Now see, now I'm pressing F for the full screen, fit screen. Sorry. Now this is the pulse. That means this you have to give it an input. So just join this and this, and move this to. Sorry. I'm sorry. Just press U to undo. Take this. If you join red and red, and if you make it pull it down, then wire will automatically be there. And after that this VDD again you have to do it the same way. You are select the ground. Now this ground is not required. Now this is the input output. Then for output again you have to select the pin, give any name, and over here I'm giving output as name, and in type you have to select output because we are making use of output. Put it over here and again join VDD to output. Now this is done. Now we have to again check and save with the same button. Check and save. See, we don't have any error. You may be asking why this is on A, like we have not connected it to our circuit, because initially when we are drawing the schematic we have given VDD and VSS. That means it is taking directly through chip. So this connection is to give power supply to the chip. This entire thing you consider it as a chip. Now we are done. Now how to get the output? For that you have to go to tool, you have to select SAE, and over here you have couple of settings. First setting is you have to go for setup analysis. In in that you just give step time step time step. Let's give 10 nano, 10 pico and 100 nano. It again depends whatever you want you can give it. So let's, it's 10 pico, 100 nano, and then click apply, and then go for DC. Over here what you have to do is source name. You have to click this mark. And in this layout, where is our in this test bench, where is the source? This is the source. You just click on this. See, it has taken its related file /v1. It may vary. It depends on don't think that if you are doing it for the first time you will be getting the v1 only. It may vary by system to system. Now start time you can give it any value. Let's give 1, and stop time let's give any value 1.2, and step size is like 0.01. Click apply and then OK. Now again go to setup and model file. In model file you have to select the file from here, and this file should be Now for this model file you have to select SAD underscore PDK90, and in that you have to select HSpice, and this library file you have to include it. Press open, and over here you have to give TT underscore 12 as a setting. Now click apply and OK. Now as you can see, we have selected transient and DC, and it is showing over here transient and DC. Now you have to declare the variable which you required in your output waveform. So first one is Vout, and over here see expression. For expression you have to click this symbol, and from this you have to select the V output wire. This is the V output. See it has selected the related wire. Now again we want V in. Again you have to select the input wire. Okay, it is the input wire. Now we are done with all the settings. Now in the analysis part, for both the things you have to select AC, transient. It depends, which type of analysis you want to do, AC, DC. Now we are done. Now we have to save our states. Whatever we have defined right now, save state, and please select open access only over here, and this name if you want you can change, otherwise leave it, and press OK. Now you have to go for simulation to get the output waveform, and then press netlist and run. Just wait for the simulation window. It is going through all the different. It is running right now. See, realization. See, as you can see over here, you are getting a waveform. Now it may be wondering. You may be wondering, what is this? You cannot see any wave over here. Now you can see here green is represented, like Vout is represented by green color, and yellow is for like V input. Now you cannot see from this. You can see that 0, 1 you are getting. Now to get the output, in easily you can see. Then you have to ungroup the waveform. See, that means, see why you are getting this error. See, when this is DC, this is DC, so you are getting some see why you are getting 0, because we have not given any value to the power supply and all. So let's go back, press OK, exit, and just click on this. Now again, what the mistake was, you have to give VDD supply. You have not given any supply voltage. So what you have to give values, you have to change it, the property. So just click on this, press Q. You will get this window, and in this you have to select DC value as 1.2 and apply changes, and in pulse just give 0 to 2. See, what is this voltage 1 and voltage 2? Voltage 1 is one level, voltage 2 is another level. So if voltage 1 is 0 and voltage 2 is 2, that means your wave will have output from 0 to 2. Not output, your input waveform will be ranging from 0 to 2, and again it will come to 0 and then 2. Give delay as 1 nanosecond, rise time as 1 nano, fall time as 1 nano, pulse width 200 nano. It depends whatever you want. 200 nano. Now click green button. Now again go to tool, SA, session, load state, because we have already defined it. Click open access, press OK. It is already done. Now go to simulation netlist, select OK. See, it's running. Now you can see over here, just ungroup it. Now you can see over here, the green one is V output and next is input. See, when input is 1, output you are getting as 0, and in the beginning you can see when the input is 1, input is 0, output is 1. So this is how you have to do the simulation using Cdesigner. And in the next video we'll be posting how to put layout, how to draw layout, and you have to go for DRC LVS settings. We'll be posting it in next video.